Here we're going to look at how to write the equation when we're given a picture of an exponential graph. The first example that we're going to look at here on the left, this is a graph of the equation y equals 2 to the power of x. We call these exponential graphs because that x variable is up in the power position, up in the exponent position. So this is going to be an exponential graph. Let's have a look at a table of values to see how this works. So I'm going to choose some values for x, and we're going to substitute that into our equation to find the matching y value. So 2 to the power of x, what if x was negative 3? 2 to the power of negative 3. When I have a negative power, something to a negative power, I can rewrite that as 1 over 2 to the power of 3. So that will be 1 over 8. What if x was negative 2? 2 to the power of negative 2 is 1 over 2 to the power of 2. 1 over 4. 2 to the power of negative 1 is 1 over 2 to the power of 1, which is a half. 2 to the power of 0 is 1. Any number to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. So, looking at those points now from my table on the graph, if x was negative 3, y is a really small value there, an eighth. If x is negative 2, y is a quarter, negative 1, a half, 0, 1. That point there, 0, 1, is a really key feature for our exponential graphs. Carrying on, if x was 1, y is 2, then 2, 4. And we can see that as we keep going up, as our x values increase each time, we are doubling. So 8, then 16, then 32, then 64, and so on. That is because my base number in my equation was y equals 2, base of 2 to the power of x. Something that we notice about this picture here, this graph, is that it's got this almost flat looking line there as we're going back into our negative values for x. We can see that as we're going back, we're halving each time, and we're getting closer and closer and closer to having the y value be 0, but it is never ever going to reach a y value of 0. On our exponential graphs, we can draw a line across here like this, and we call this line the asymptote. This means this is the line that our values are going to get really, really, really close to, but it's never actually going to touch that line across the x-axis, across the line y equals 0. So that asymptote, that line there, and this value 0, 1, that is 1 above the asymptote, those two things are really key features to note on our exponential graphs. Looking here on the right at two more examples. So that black line here again is y equals 2 to the power of x. That's the first one we looked at. This blue one here, let's look at this. It goes through the point 0, 1, and that is because any number to the power of 0 is 1. So it goes through that point as well. We can see that it's got an asymptote. Here it's flattening out and getting really, really close to the x-axis, to y equals 0, but it is never going to reach that. So that is our asymptote. And if we put a few more coordinates on there, we can see this was our key point 0, 1. The next one across is 1, 3. We can see that is 3 above the asymptote, so the equation for this is going to have a base of 3. My equation is y equals 3 to the power of x. And so every time my x increases by 1, it is tripling because I've got that base of 3 there. And then let's look at our purple line. So we can see again it crosses through the point 0, 1. The next one is 1, 5. the next one's going to be up at 225. I can see again that here is my asymptote sitting along the x-axis, goes through the point 0, 1. That next point is 5 above the asymptote. This graph is y equals 5 to the power of x. We can see that if we've even just got a small change in our base number, the graph becomes a lot more steep. So just a small change in that base number changes the look of the graph quite significantly. Up the top here is the general format for the equation of an exponential graph. This b here represents the base number. Up here, that minus c, that represents the horizontal shift. And the plus d on the end, that represents the vertical shift. So on these graphs here, the black dotted line, that is our first graph that we looked at. That is y equals 2 to the power of x. Let's look and find the equation for this red graph. I can see that that graph is getting really, really close to, but never touching, this line across here. This is the asymptote for this graph, and that has been shifted up from the x-axis by 1. That is now the line y equals 1. So I know from my equation that it is going to have a vertical shift of plus 1. So the asymptote's really important. I've looked at that. Now I need to look at the point that is 1 above that asymptote. So looking along that line, here it is. That point there is 1 above the asymptote. Usually on my black original y equals 2 to the power of x, that point was here at 0, 1. We can see that on our new graph, our red one, it's up there, and it hasn't shifted to the left or the right at all. There's only been vertical shift for this graph. So that minus c up there is actually 0. There's nothing happened there. So I could actually just write it b to the power of x plus 1. So I'm not plussing or adding or subtracting anything in the power. Last thing I need to find out is the base. And I can look, and from that point that's 1 above the asymptote, I go to the next point, and I see that that is 2 above my asymptote, so I am thinking that my base is going to be 2 to the power of x plus 1. I can check that I've got the right formula by picking another point on my graph that I can read and substituting that in. So that point there is 2, 5. I can read that nice and easily, so I'm going to substitute that into my equation. So I think this is my equation. So I'm going to substitute in x is 2 and see if it comes out with 5. 2 to the power of 2 is 4 plus 1, y equals 5. Yes, that matches the point on my graph there, so I know this is my correct final equation. And looking at this orange graph, I am going to check, first of all, where is the asymptote? And I'm going to draw my dotted line. Here is my asymptote. That hasn't shifted up or down at all from where it normally is, so I know that there's no vertical shift on the end. So my equation is going to be plus 0 or nothing on the end there. Now I'm going to check, has there been any horizontal shift? So I go to the point that is 1 above my asymptote. Here it is. Usually that is right in line with the y-axis, but it has shifted to the right by 1. So that changes what goes up in the power. Y equals the base number, x minus 1 is the power. Remember that horizontal shift is opposite of what we would expect. Just move to the right by 1, so we put a minus 1 there. And we now want to check, lastly, what is our base number. Here was my special point. I go to the next one along, and I can see that that is 2 above my asymptote. So I'm thinking my base is going to be 2. I'm going to pick another point that I can read and use that to check my equation's correct. I can read that as 3, 4, so I'm going to substitute x is 3 and solving that, 2 to the power of 2, y is 4. Yes, that's what I expected there. So I know that the final equation for this graph is 2 to the power of x minus 1. And here is the final graph that I'm going to find an equation for. The first thing I look for is the vertical shift. I can see that the asymptote, the graph is getting really close to this line here, y equals -2. The graph has been shifted down by 2, so I can start writing my equation, and the vertical shift is going to be -2. Next, I'm going to look for that special point that is 1 above the asymptote. There it is there. Usually that's in line with the y-axis, but it has moved to the left by 3. So my power is going to be x plus 3, opposite of what I would expect for the horizontal shift. Still got that vertical shift of -2. And the last thing to find is the base. This was my special point. I'm moving along to the next one. There it is, and I can see that that is 3 above my asymptote. So I'm thinking my base is going to be 3 to the power of x plus 3 minus 2. I can check that I've got the right equation by finding another point on the graph. That's -1, 7, and substituting that in, checking that it agrees. So y equals 3 to the power of x is -1, plus 3, and then minus 2. That would be y equals 3 to the power of 2, minus 2, y equals 9 minus 2, which equals 7. So that agrees with those coordinates there, so that I know that my final equation is y equals 3 to the power of x plus 3, then minus 2.